Hi everyone, Mr. King here. We're going to go over a classic algebra mixture problem right now. This particular problem is built in a way that makes it a little bit different from the classic problem where you mix different concentrations of salt water together to create another mixture of salt water that has maybe a slightly different percentage of salt in it. In this case, we're dealing with gasoline octane, which it's not exactly like salt. Octane is a property of gasoline. The higher the octane, the more the gasoline resists detonation, that is exploding, when it's compressed in the cylinder of an engine. So different cars have different compression ratios, and the ones with higher compression ratios typically need higher octane gas so that the engine runs right. In this particular problem, we have an 18-gallon gas tank, and it already has 92 octane in it, the required octane for the car, and the owner is going to fill the gas up all the way, so it needs to have 18 gallons of 92 octane, but the gas station only sells 94 octane and 87 octane. So the idea in this problem is we want to mix 94 octane gas and 87 octane gas in certain quantities such that when we combine it with the gas that's in the car already, we get 18 gallons of 92 octane. So our unknowns in this particular problem come from the question. How many gallons of 94 octane? How many gallons of 87 octane? And so those are our variables. So I'm going to let x equal gallons of 94 octane gas, and I'll let y equal gallons of 87 octane gas, like so. Our next step in this problem is to build some equations. One of our equations can have to do with the total amount of gas. We know that we have 6.25 gallons of gas in the tank already. We're going to add some 94 octane gas, x, and some 87 octane gas, y, and the total must be 18. Well, this equation can be worked, if we take 6.25 from each side, we see that x plus y must equal 11.75. So there's one of our equations. The other equation we're going to need to solve this problem has to do with the amount of octane, if I can call it that. And this is really analogous to saying if we were mixing saltwater solutions, the amount of salt in each of the buckets that we mix together into the big bucket must be the same as the amount of salt that we're going to have in the big bucket when we've mixed it all. So here, we're going to mix different octanes, and when we look in the tank, we better see that we have all that octane content, if you will. So that may be a bit of a conceptual leap, but it's going to allow us to set up another equation, and then we'll have a system of linear equations that we can solve. And so here's how this works. In a saltwater problem, we'd multiply the percentage of salt times the amount of that salt percentage solution. Here we're going to multiply the octane amount, for example, 94 octane times x, the amount in gallons of 94 octane gas. We're going to add to it the 87 octane, and we're going to be getting y gallons of that. And this must, of course, add up to the amount of gas that we're adding, which is 11.75 gallons. And its octane is 92. I could have written it as 92 times 11.75, so that the form is the same as on the left side. This is our second equation. Now, this particular system of equations lends itself to being solved using substitution. So to do that, I'm going to go up to the x plus y equals 11.75, and we're going to solve for y. Y is equal to 11.75 minus x. That can now plug in for y in the second equation. So we get 94x plus 87 times 11.75 minus x equals 1081, like so. This leads to 94x plus, well, let's see, 87 times 1175 is 1022, 25, and then we get minus 87x, and that's equal to 1081, like so. And then we can combine things. The 94x minus 87x is 7x, and then 1081 minus 1022, 25, well, that's going to give us a 75 on the end. 11 minus 2 is 9, 7 minus 2 is 5, so that's 59, 75. We can divide each side by 7, and that gives us x equal, well, that gives us x equal to 8.54. But as I look back, I see that I made a mistake, because I don't do this kind of subtraction that often. Do you guys see the mistake? I didn't borrow this guy over here to get to 75. So that means I really had a 0 here. A 10 minus 2, that's an 8. That should have been 58.75. And that gives us 8.39 gallons for x. And that's the amount of 94 octane gas we need to buy. To find the amount of the other gasoline, we simply go over to our equation, and we see that y is equal to 11.75 minus 8.39, and that gives us 3.36 gallons of 87 octane gas. And those are the amounts of 94 octane and 87 octane gas that solves this problem and fills our gas tank with 18 gallons of 92 octane gas. I hope this explanation made some sense for you. Thanks. King Pre-Calc, over and out.